Okay, good day, class. Today we are going to be looking at the second session. In the second session, we'll be looking at multiple agents. That is, building multiple agents with CrewAI. Why do we have to look at this scenario? One agent, like we saw in the last example, has just one voice. And in the real world, we need several of such voices. An example is maybe you are building an agent and we need a critic, one that critiques, what is being done, and another one that probably recommends. Okay. We could also have a situation such as an optimist and a pessimist. Okay, where one is optimistic about what is to be done, while the other is pessimistic. So then we try to look at both of them's, outputs to refine our agent. So sequential crews let each specialist to do their own task in order. So in this case, where we have multiple agents, each of them doing their task as expected to, and sometimes each of them, contributing and making the task of the other one better or enhancing it. So, or enhancing the task of the other. So in this situation of building multiple agents, we could have it played in different scenarios. Like the examples I mentioned, such as one that critiques and the other that recommends, one that is optimistic and the other that is pessimistic. Sometimes each of these agents do their own thing while contributing to the end goal of the task. And sometimes each of them work hand in hand, work together to ensure that the output is being done. So for example, we could probably have an agent that argues in support of a particular argument, while the other, argues against that particular argument. Or you could have an agent that writes and the other one corrects or enhances what the first one did. So we could have these agents play in different scenarios. So, and having two heads, having multiple agents is of course always better than having one. If you look at the example of what we did earlier, we talked about an agent that motivates someone to go out for the gym, right? Such agent is good, right? But let's also think of maybe you have another agent that reviews what the first agent wrote, and that could also enhance the output of the overall agent, right? So having multiple agents is one thing that is always better than one, and oftentimes they work to collaborate to enhance, the overall quality of the task that is to be delivered. So the learning objectives of this session is one, you'll be defining two agents with distinct roles and personality. In this case, we'll be building two different agents, with each of them with their own roles and their personality. And also, we are going to run tasks such as process sequential. Of course, I believe you know by now that is to run sequential agents, where each of the agents is to run their task, one independent from the other. Then also, by the end of this class, you should be able to give each agent its own dedicated task and also recognize when sequence matters and when it does not. So look at how that plays out before the end of this session. So the process of sequential, what does it mean? It means a sequential process run tasks in the exact order you list them. Each agent handles its own task. The output prints one after the other. No agent sees another agent's output yet. That comes later with context chaining. Think of this as two independent specialists, each writing their own section of a joint report. So yes, in this case, while using this process of sequential, don't forget I mentioned it earlier. The process of sequential is to ensure that the agent runs its task or performs the task or executes its task sequentially, right? Sequentially, and that's what it does. So in this case, since you are going to be having two different agents, what this process of sequential is going to enable them to do is to ensure that each of them have their own task and they do their task, each of them independent of the other. That is, whatever it is that one of the agents is doing is, completely hidden from the second agent. They have no idea of what each other is doing, but at the end of the day, they could be used towards the overall output of what is needed. Think of this. For example, we are trying to maybe you are trying to write a book, for example, or you're trying to do a particular thing that, okay, probably one is writing and the other is, creating images for what is supposed to be written, right? So one does not need the output of one to be able to do its own task. So they just do their own thing as expected. So think of that as this, where we have two agents, each of them working independent of each other, and they all collaborate towards the an end result. So here is what we have. Agent A, is a critic of a book, while agent B suggests a book, and then we have a final output. So we look at how that plays out. So here is the code anatomy. Here you have code agent A plus B. These are two different agents with different goals, roles, and backstories. Max eta equals 2. So here you have optional safety cap to stop the agent from looping forever. We'll look at that when we write the code anyway. So in this case, you have critic reviews of atomic habits, then recommender suggests similar book. So here is what we are going to be expected to, what's expected to, have. A is a 3-sentence critique of atomic habits, followed by one recommended book with a 2-sentence explanation. I guess someone has a question.
Yes, sir. Your screen, we are just seeing the first page of the slide.
Really?
Yes.
Are you seeing it now?
Yes, sir.
Okay. So here you have the critic. So we're having two agents in this case. One, we're having the critic, and the other is the recommender. So what the critic does is it critiques a particular book, while the recommender recommends a similar book. Okay? That is what is expected to be gotten by the end of this. Now, so here we have this. So what you're going to be taking home as the assignment after this, you're going to run a debate on social media, one optimist and the other pessimist. Give each two reasons for their debate. So by the end of this, you're going to be taking your assignments, which I'm expecting that by now you note this. The assignment will be to run a debate on social media. On social media, that is, the agent is going to debate about social media. One is going to be optimist about social media, while the other one is pessimist about social media. And each of them will be giving two reasons for whatever it is they are thinking about. Yeah, so here are some things you can note as well. Okay, common errors. I think we've looked at this in our last session. Okay, so again, we are going to be looking at two distinct agents, each of them running sequentially independent of each other. Yeah, they run sequentially to execute a task. Don't forget the kickoff function returns the last task output. Okay, so let's go to the code. So just give me a minute. Let me try to create notes. Let's try to. Okay, can we see my screen now?
Yes, sir.
Okay. So to start with, like we did in our last session, the first thing is to import required libraries. Okay. So the first is import OS. So don't forget that we have four functions to be imported from CrewAI. So you say from CrewAI imports agents. So this is the function we use to define the agent. We have the task. Don't forget there's the task to be given to the agent. We have the crew that brings the agent and the task together and monitors it. And then we have the process that runs, that monitors how the agents are going to work with each other or how they are going to run. So don't forget, you are going to, since I've stored my API or config credential keys in .env file, so I have to, import load.env to be able to load those credentials from the env file. So here I have .env imports load underscore .env, right? So the first thing is to have this, then Gemini model, okay? So I'm going to specify the Gemini model I'm using. Okay, I'm using 2.5 Flash. Now, the first agent to be defined is the Optimist. So let me call that agent 1. It's 1. It's the Optimist. So here you have agents, row. So here you have Optimist beta. Now, so we have the goal. So here you have the goal is to debate with optimist point of view, right? Don't forget, is an optimist and it's going to be optimistic about his views. Okay, to debate. Mm. Sorry, this is supposed to be a function, not a string. Okay. Now the next is you have a backstory. There you have this. Now the backstory is you're an experienced debater with many years of debating from an optimistic perspective and always wanted to see things from the positive perspective. You're honest, factual, and realistic, but always positive. So you can write anything that comes to your mind, uh, in just for you to be able to define the optimistic views or to define the persona of the agent. And in this case, since you want it to be optimistic, so we are going to define its backstory in that direction. So you can say something like you're an experienced creator many years of experience of debating it's okay. So that's that. Then the LLM you are using, don't forget, we have LLM, what is the Gemini model, and also we have verbose. We have max iteration. Max iteration is 3. That's the maximum number of iteration it can go in trying to come out with an output. So after writing the role of the first agent, so you do that of the second agent as well. We call this agent 2. This is pessimist. So you define this as well. So the role is what pessimist data. Then the goal is to debate with pessimistic point of view. So you have to then we have a backstory. Backstory is just going to be the same, but optimistic we change to pessimistic. I'm just going to put that here and edit those things. So you're an experienced debater with many years of debating with pessimistic. Pessimistic perspective and always want to see things from negative points of view. So we have LLM because the Gemini model. We have levels. maximum iteration. Now, so we are going to give a task to each of them. So here we have optimistic task. So we have this task. You have description. Here you have give 2 reasons why social media is good for society. Okay, don't forget that's what we asked it to do. And also the expected output. What's the expected output? The expected output is a 2-sentence explanation, 2-sentence paragraph explaining why social media is good. Okay, the agents. What agents are we using here? We're using optimistic. Optimist, yeah. Okay, so um, that's the description. The expected output is a 2-sentence paragraph. Where social media example setting. So here there isn't here is now don't forget you're going to be having a critique, which is the one that takes both the agents and their task together to ensure it is being run as expected. So here we have crew function. The first argument it takes is the agent, right? So here we have the optimist, we have the pessimist. And then we have the tasks. So here we have the optimist task. We have the pessimist task. Okay. And the next thing is the process. That is, how is this going to run? So we have the process plus the variables equals true. They will store the results here. Critic dot speak of yes. They will print the results. Yeah, so this is what we will be using. So here we have Python. Okay. Hmm. Looks like this was the error I had in our last class. Uh, Minutes. Was everyone. We try variable first slash grades first slash active grades. So I have quite a lot of virtual environments. So let me see which one worked in our last class. Oh. Oh. Just give me a minute and try to get this. Okay, so let me deactivate this. Okay, so let's run it here and see. Oh, CrewAI is not defined here. Okay, if install CrewAI. You know what? Let me just cancel this. I'll deactivate it and I'll run it on 3.11 Python. Sorry, Crew plus student Q1. Yeah, so let's see this. Just give me some minute to just a little bit of time to figure this out.
Okay, sir.
Yeah. Okay, so looks like it's installed now. Uh-uh. So yes, troubleshooting code is also part of your job as a programmer. Sometimes you encounter these things and how to find your way to us, you know. So this most likely version dependency issue. But we'll look at it anyway. It was similar to what I had, but I did not document what I did in my last. I did not document what how I was able to solve it in my last time. Yeah, I should just. Let's see. Description. So just give let it finish, then I'll take you through what I'm doing or what I was able to do. Okay. So then this again, what is this? Google generally need to provide. We had we had It is well. Oh, okay. So sorry, the error earlier was Python version. So I had different Python versions, and the default one was 3.8. So the default one was 3.8, and I'm trying to install dependencies of higher version on it. So it wasn't compatible and it was returning error. So the last one was talking about Google Generative AI native provider not available. So it's asking me to install CrewAI with Google Generative AI dependency on it. So I had to do that. CrewAI, Google Gen AI. I quickly installed that. That was the last update that I did. And with that, we are set fine. And then I just ran with the Python script. And this came out. So you can see here, the task started. Give 2 reasons why social media is good for a society. And you can see for the Optimist, it was saying social media signed as a wonderful platform for fostering global connection, allowing individuals to build support, blah, blah, blah. Then that was the end of the Optimist debate. Then for the Pessimist, you are saying give 2 reasons for explaining why social media is harmful to society. It's saying social media invariably cultivate an environment of constant comparison and curated perfection, leading to widespread anxiety, depression, and a pervasive sense of inadequacy, and so on. So yes, that brought us to the end of that. So here we now have the final output, which says social media invariably cultivates an environment of constant comparison, this and this and this and this. Okay, so which was the last output, and that output was that of the pessimist. And don't forget, I mentioned it that we are going to the kickoff is going to be printing the last response from the agent, and since the pessimist gave the last response, we have that as the final completion. So yes, this brought us to the end of this session.